All right, hello everyone. Welcome to the third part of the video now for section 2.3, and there's one more example I want to go over, and so we will do that. So first of all, here is the problem. So we're asked to find the area of the triangle that is bounded by the x-axis, the line f of x equals 12 minus 1/3 x, and the line perpendicular to f of x that passes through the origin. Holy, what is going on there? Okay, so first thing I'm going to do here, there's a lot of information here, is draw a picture, which, as I mentioned at the beginning of this section, is a great way to organize your thoughts and also help you see what's going on. It can be a really powerful tool. And it says we're going to find an area of a triangle. And that triangle is, first of all, bounded by the x-axis, or the horizontal axis. So one side of the triangle will be this. It's also bounded by the line f of x equals 12 minus 1/3 x, which we recognize as a linear equation. So we need to graph that. Before we do, I need to put some labels on my axes. And so what I'm going to do is on the vertical axis, I'm just going to count by ones, but since that's not going to fit, and oh my gosh, now my highlight went away. Hold on. Okay, highlight's back there. I'm going to count by twos on here. So 2, 4, 6, 8, 10, 12 there. And along the bottom, because I know how this problem works, I'm going to have actually 6, 12 here, 18, 24, 27, and I think I screwed up somehow, 6, 12, 18, 6, 12, 18, 24, 27, 12, 15, 18, 21, 24, 27, 30, 33, 36. Oh, right, so this should be 33. I know what the problem is. Right here, this should be 30, 36. Okay, sorry about that. And this one's supposed to be a 24. All right, so I'm going to draw the line f of x equals 12 minus 1/3 x. And so I'll start by identifying my vertical intercept, which in this case is going to be 12. My slope is negative 1/3, which means from there I can go down 1/3. But notice that the way I've counted along here, each box actually is going to be 3. So go to down 1/3 is actually going to put me here, and then here, and then here, then here, then here. So we go on forever like that. And so what we see then is that our line is going to look something like this. Okay, if you connect all those dots. And so that's going to be f of x equals 12 minus 1/3 x. And then here is the part we have to read very carefully. So it says the other thing that we're bounded by is the line perpendicular to f of x that passes through the origin. So what is that saying? Well, it's saying we have to find a line that's perpendicular to f of x that also goes through the origin, which the origin is going to be this point down here. So that's going to be 0, 0. Okay, we need to find a line that's perpendicular to f of x. Well, recall that if the line is perpendicular, then its slope compared to the slope of f of x will be an opposite reciprocal. So the slope there will be, instead of negative 1/3, it'll be the reciprocal of that, so 3/1, and the opposite's a positive 3/1. So the slope is going to be 3x, or sorry, just 3. And our equation for this line will look like 3x plus b. Remember, the value for b is the vertical intercept, which in this case, since it goes through the origin, is just 0. So we're looking at here is a function that is g of x equals 3x, which if I then starting the origin here, since that's my vertical intercept, go up 3 over 1, up 3, 4, 5, oh yeah, right, got it. Sorry, over 1, up 3 over 1, and then up 3 over 1. So our line will look something like this. Okay. And recall that it's perpendicular to the red line. So even though it really doesn't look like it because of the scale of my picture, this is actually a right angle here. Okay. So now we've at least got the triangle set up. But what else do we need? Well, we need to find the area of that triangle, right? And recall that the formula for the area of a triangle is 1/2 base times height. So we need the length of the base as well as the height of this triangle. And I'll tell you, the best way to do that is to first of all call this your base down here. Okay, and notice that basically what you need to do there is find this point for the red line, which what is that point, or what's it called? Right, that would be the horizontal intercept. So you'd need to find the horizontal intercept at that point. That'll help you find this length. Then we also need to find the height of the triangle, which height is always measured perpendicularly to the base. So what we're trying to find then is a line that's going to look something like this here, right? And notice in order to find that point, we need to, or that distance, we need to find the intersection of those two lines there, okay? So notice there's a lot to do here, okay? And because of that, I could make like a 30-minute video on it. I'm not going to do that. But if you look in our class assignments and handouts folder for chapter 2, you should find a handout that says section 2.3 classwork. And there should also be an answer key for that in there. Okay, and if you look at the answer key, this problem has actually been worked out all the way to completion with the answer. Okay, so here I've kind of given you an overview of what the problem would look like, but you can work through the rest of it there. Okay, and please do reach out to me or your SI if you have questions. All right, great, thanks for watching. That's it for now.